Sometime back, we built some bathroom furniture out of some beautiful hickory. I'd been saving this for just the right project, and it took a long time to find that project because a lot of furniture requires some thick stock to make legs and other components, and all my boards were just 3/4 of an inch thick once they were milled flat and straight. This is a problem a lot of folks have. How do you find 2 or 3 inch thick stock, preferably from the same tree, so it matches the grain and color of the rest of your boards, when not everyone has access to a well-stocked mill or hardwood dealer? The answer is to make it yourself, and that's what we did when we made that hickory bathroom furniture. We assembled each leg from 4 beveled strips of 3/4 inch material, making them look like solid wood. The benefits of this process go beyond just using thinner, less expensive stock to create these beefy legs that you need. They can also look a lot better than solid wood legs. Here's a chunk of solid oak. Notice how the grain is nice and straight on this face. This is the quarter sawn or rift sawn appearance that a lot of folks pay top dollar for. But everything changes when you turn it just 90 degrees. Now you have a much less pleasing flat sawn grain pattern. That's the nature of large solid wood components. They can look great from one angle, but completely different from another. This smaller example, on the other hand, appears to be quarter sawn all the way around, something that's impossible in nature. But it's entirely possible in the workshop because when you assemble a leg or a post from 4 separate pieces, you control the grain on all 4 sides. Of course, quarter sawn oak is just one example. No matter the wood you use, it pays to control the grain pattern by wrapping it around the post rather than just taking what nature gives you. In the past, I used to do this by simply cutting double beveled strips of wood at the table saw and then gluing them together. But that can be a little bit tricky. For one thing, it can be difficult to cut perfectly consistent 45-degree bevels on the table saw, especially when you're doing it to the narrow strips that are required to make a fairly small post. Frankly, it's a good way to get some nasty kickback. So these days, I prep my stock at the table saw, carefully ripping everything to its final width. These straight 90-degree cuts are perfectly safe when done with the proper safety equipment, and a featherboard or roller guide system like this one can also help ensure that each strip is precisely straight and equal in width. Then I use a well-tuned miter gauge to cut all my parts to length. I like to leave about a 1/2 inch or so on the end of each piece extra so that I can trim the whole leg once it's assembled. With that finished, I move on to the router table because this is a safer and I think more accurate method for beveling the edges, especially if I use a lock miter bit. I like these bits for 2 reasons. First, it is precisely 45 degrees. There is no way I can mess that angle up. Second, it creates a mechanical joint that is far easier to glue up and assemble. I won't even need clamps. These bits are fantastic, and don't listen to the folks who say they're too hard to set up. We made a whole video about how to set one up quickly and easily just about a year ago. I'll link to that in the description below this video, and I'll also pin the link to the top of the comment section where it'll be easy to find, along with a link to the lock miter bits that I recommend. But this time, I'm going to show you an even faster way to set it up using a digital caliper and a digital height gauge. First, I measure the full height of the bit's cutters. Then I measure the thickness of my material. I divide both those numbers in half and I add them together. That's the height that I set my bit above the table. Now this should work perfectly, but I'm still going to do a test. I cut a couple inches onto the end of a scrap and then flip it and do it to the other side. Then I cut that end off, separate the 2 pieces, and slip them together. If the surfaces are flush, then my bit height is dialed in. Setting the fence is super simple too. Place a workpiece against the fence and lay a ruler on the table against it. Set the fence so the edge of the cutter just barely scrapes the rule. You want to hardly feel it at all. Then lay the piece flat on the table and put the ruler on top of it. The cutter should just barely scrape the rule in this position as well. If it does, your fence is set. If it doesn't, your bit height is what's off and you need to check your measurements. Cutting the first edge could not be simpler. I use a pair of push blocks to apply nice even pressure both down on the table and against the fence. Do not do this with your fingers alone. If you're machining a really long workpiece, you might set up some feather boards, but in most cases, for this first edge cut, the push blocks are enough. I run all the workpieces through on that one edge. Then I'm going to make some changes before I cut the opposite edge. This one is a little trickier because the workpiece has to be run flat against the fence. And as we cut, we'll be removing a lot of the bottom edge, leaving only a narrow strip along the fence for support. So to keep everything stable and consistent, I want to stack 2 feather boards, or in this case, I'm using a high roller guide that has 2 wheels, so it applies pressure higher on the workpiece near that center strip that will remain rather than at the bottom edge where it might tip it during the cut. Again, if you don't have an adjustable roller guide like this one, you can stack 2 feather boards instead. Now ideally, you'd want one of these setups on each side of the bit so you have support as you feed the workpiece in and you maintain the support as it comes out of the cut. But since these are short workpieces, I'm just using a paddle to keep pressure on the fence as the workpiece clears the bit and the cut is done at that point anyway. The roller guide and the paddle only keep pressure against the fence. The downward pressure and the forward motion come from a custom pusher I made from a scrap of plywood, which I profiled by running it flat on the table at the same lock miter bit setting. Then I attached a strip of wood at the heel. The profile easily slips over the top edge of my workpiece, while the heel strip hooks onto the end to move it through the cut. This custom pusher is much easier to use compared to the paddles alone, especially when you have a featherboard stack or a roller guide in the way. Now you get to see the real benefit of using a lock miter router bit to bevel these edges instead of the table saw. The parts slide together so nicely, and it's almost self-squaring. The mechanical lock along each seam prevents glue slip, so you can use clamps if you like, but you could also just skip the clamps and use rubber bands or, my personal favorite, blue tape. If after assembly and glue up, you find some openings in your seams, don't worry about it. Just burnish the edges with a screwdriver, compressing the fibers together and sealing up any cracks. Once you have the ability to build your own legs and posts, a whole new set of furniture projects will open up to you. Don't forget to check out those links below, and we'll see you next time. As the builders behind some of the top brands in the industry, Harvey Machinery has for decades been letting others take credit for their innovation. Now they've developed their own line of saws with the quality and features once reserved only for professional shops. The woodworking world is officially on notice. Harvey Machinery will be in the shadows no longer.